Hello again, guys. We are doing one more lesson about vectors. This last lesson is about what's called the dot product and how you can use it for different things. So the first thing that I really need you to understand is that the dot product works differently than addition and subtraction like we've already done, is it actually is going to yield a scalar answer, which means just a number answer instead of a whole vector answer. So that's kind of what's weird here. So this is your formula for the dot product. You're going to multiply the horizontal components together, plus then you're going to multiply the vertical components together. So you're going to end up with two numbers, and you're going to add them together, and you'll just get one number in the end. The next box shows you that the properties pretty much of multiplication also apply to the dot product. So it's commutative. You can switch the order. If you multiply by 0, you get 0. You could distribute with the dot product. This one's pretty interesting, is it says that the magnitude squared is the same thing as multiplying a vector by itself, so you can kind of use this instead of using the magnitude formula is all that's really saying. And then the last one just gives you another example of if you were multiplying a group that you would only multiply one of them by C, that you wouldn't actually distribute across multiplication, you only distribute across subtraction. So let's look at some examples. In this one, in the first example, again, it's the first two get multiplied by each other. It's going to be 3 times 2. Then it's a plus sign. The last two get multiplied by each other. 4 times negative 3. So that's going to be 6 plus negative 12, which gives us that the dot product is negative 6. In the next example, we would do negative 1 times 4 plus 2 times negative 5, which is negative 4 plus negative 10, and I get negative 14. And if you want to pause for a minute and try the last one, I'm going to start it in 3, 2, 1. It's 1 times 0 plus negative 6 times negative 2. 1 times 0, remember, is 0. I see that happen every once in a while that people forget that. And then a negative times a negative is going to be positive 12. So our dot product here is just going to be 12. So now these next ones, the operations just get a little bit trickier. So in number 4, they want us to do U, which is 3, 4, dot V, which is negative 2, 6. Those are inside parentheses, so we're going to go ahead and do those first. And then it's times W, which is 1, negative 3. So in order to do this operation, we're going to do the dot product on the inside of the parentheses first. So it's going to be 3 and negative 2, which is negative 6, plus 4 and 6 is 24. It's 1, negative 3. On the outside still, we're going to continue to simplify inside here. So this is really 18 times 1, negative 3. So now the dot product gave us a scalar, and we're going to do the scalar times the vector. So remember, that just means to multiply each part by 18. So our answer is going to be 18, negative 54. Alright, in number 5, we're doing U dot 2V. So I'm going to write U first, 3, 4, dot 2 times V. So we're going to do the scalar multiplication part of this first, is we're going to multiply that 2n. So it's 3, 4, and then it's going to be negative 4, 12. And then we'll do the dot product here. It is the dot product, so it's going to be the first two multiplied together are negative 2, plus the second two multiplied 4 and 12 is 48. So we get an answer of 36. If you wanted to check, we could have actually done the dot product of the two vectors first, and then multiplied that answer by 2, and we would still also get 36 as the answer. So the order doesn't matter because it is multiplication. Alright, the last one is asking you for the magnitude. So remember that those symbols mean magnitude. You could just use the magnitude formula, or you could use the new formula that they told us. The new formula says that we could do the dot product of that times itself, and that's going to give us the magnitude squared. So then we would just have to take the square root of what our answer is in the end. So I'm going to do it that way just to practice the dot product. But you could also just do the regular magnitude formula of the square root of a squared plus b squared. So I'm doing the dot product on the same vector on b twice. So it's going to be 4 plus 36. So essentially what happens is we're squaring the two numbers, and we get 40. And then if we took the square root of that, that would give us the magnitude. So it's the square root of 40, which is not a simplified answer. That's really 2 radical 10. So that's our magnitude. Alright, this next part just shows you the math. This is just a lot of complicated math of if we wanted to find the angle between two vectors. So right now we're focused on vector v and w. If I wanted to know the angle between those, the theta, we could draw in another vector called u, and we would make a triangle here. It's an oblique triangle that we have side, side, side for. So if you notice here, they're using law of cosines over here to work this out. So this just shows you law of cosines worked out, giving the vectors that we have and the coordinates that they have right now. And it shows you that it really ends up just being at the end that we end up with the dot product of v times w is equal to the magnitude of vector v and vector w times the cosine of theta. But the cosine of theta doesn't just come in there randomly. It is actually from the law of cosine. So you can look through all the complicated math of it, but I wanted to show you where it was coming from. So this is our formula we're going to use if we want to find the angle between two vectors. It's the same formula that was up there first. This one, it's just solved for cosine. We just divided. And this one has a u and a v instead of a v and a w. So that's essentially if we have these two vectors and we want to find the angle, that's how we're going to find the angle there. So we're going to do that on the next page. So that formula was cosine theta is equal to u dot v over the magnitude of u times the magnitude of v, just so we have it. So in this first example, we would do cosine theta is equal to, the dot product is what we're going to do on top, so it's going to be negative 2 plus 12. The top is really going to be 10. And then on the bottom we have to do the magnitude, so it's going to be the square root of negative 2 squared plus 3 squared, and then it's going to be the square root of, for v, 1 squared plus 4 squared. So that's going to be the square root of 4 and 9 is 13. Square root of 1 and 16 is 17. And at this point, I'm just going to turn that into a decimal on my calculator. You should get 0.6727, and then we'll do arc cosine of that. And we get that theta is 47.73 degrees. Okay? Just to show you visually, you don't have to do this for every problem, but just to give you the visual, if we were to graph these, I just want to show you that that's actually what's going to happen here, and I'm just going to be a little bit more accurate than we normally are in graphing them. So the first one would have been over 2 up 3, and that would have been our vector there, and then the second one's over 1 up 4, that would have been our vector here. So if you look at that, that is definitely an acute angle, so an answer of 47.73 degrees would work. This will also give you obtuse angles as well, so that's the nice thing, since it's cosine in the formula, it's going to give you either answer. You just have to work with the formula. So if you want to take a minute and pause and try number 2 on your own just to see that you understand how to use the formula from start to finish, this would be a good one to try on your own, and I'm going to start it in 3, 2, 1. Alright, so if we want to solve this one, we're going to do the same formula. Cosine theta is equal to the dot product goes on top, so it's going to be, for this one, negative 6 plus 20 over the magnitudes are going to go on the bottom, so it's negative square root of negative 2 squared plus negative 4 squared, and then for v it's the square root of 3 squared plus negative 5 squared. So we get positive 14 over square root of 4 and 16 is 20, and I'm just going to leave them unsimplified. You don't need to break them down. And then 9 and 25 is 34. So then that's cosine theta is equal to, I get 0.5369. I'm going to do arc cosine of that. Theta is 57.53 degrees. So this one again wasn't obtuse, but you'll see that it's obtuse if you get a negative number on top. So when your dot product comes out negative, you'll get an obtuse angle there instead. Those are going to have a farther distance away from them when you graph them as well. Alright, the last application of the dot product is to decide whether or not vectors are orthogonal. So two vectors are orthogonal when the angle between them is 90 degrees. It's pretty much the same. It's the same situation as what we get when we talk about perpendicular, but perpendicular is talking about two lines. This is the word we use when it's two vectors. We call them orthogonal. So what I want to show you is what happens when we do this formula that we've been talking about. V dot W is equal to the magnitude of V times the magnitude of W of cosine theta, is when we evaluate that in an orthogonal situation, we actually know what theta is already. Theta is 90 degrees, so I want to show you what happens here. So if we do V dot W equals magnitude of V, magnitude of W, cosine 90, if you had looked on your plate or if you do your finger trick, cosine of 90 is actually 0. So that all turns into 0, and that turns into 0 on that side, which means that whole side actually is 0. So if you notice, the dot product equals 0. So that's how we're going to be able to test to see if it's orthogonal. We know that that two vectors will be orthogonal if and only if their dot product is 0. So that's our next question for this one. So you need to know what step you're supposed to take when it asks you that in the directions. The directions ask you, are they orthogonal? To determine that, you need to know that you're going to use the dot product. So that's all you got to do here. You have to use the dot product and see what number you get out. So we're going to do negative 6 times negative, or times positive 8, plus 4 times 12. That's negative 48 plus positive 48, which is 0. So our answer here is yes, they are orthogonal because we get a dot product of 0, which means the angle is 90 degrees. And then here's just one more example. This is negative 3 times 2 plus 6 times 0, which is negative 6 plus 6. We get negative 6, so this is no, these are not orthogonal. Alright, so hopefully these lessons went pretty well for you guys and they make sense. Make sure you're keeping up with the homework because we are going to take a homework quiz on Friday on everything that's been covered. I've been posting the answers. I've been posting videos for the ones that people have said they need help with. So just make sure you're looking at the answers, looking at the videos, so that your homework is 100% correct when you walk in on Friday. Alright, enjoy your last snow day off, stay warm, and I will see you guys on Friday.